All right, the lesson here is on inscribed angles. Again, we said that we were going to discuss a few different angles, actually a couple different angles. The first was central angles, which is what the bell work here pertains to quite a bit. And then we have the inscribed angles. Again, that is the focus of this section. You need to make sure that you maintain the difference between the two and are able to work back and forth between the two. Okay, so make sure you understand them. So for the bell work here, we're going to find the measure of each of the following arcs. Okay, and my suggestion when you get something like this is to go ahead and take the figure that we're given and fill it out as complete as possible. Okay. Again, you're going to focus on some small things that you should know. Focus on the fact that a circle has 360 degrees total. Focus on the fact that a half of a circle is 180 degrees. Okay, so if I look at this circle, I should be able to see that from E to B, this is a straight line. That is then the diameter of this circle. Okay, and with the diameter of the circle being from there to there, what I'm going to do is then take the fact that this is 180 degrees here, and I'm going to take 180 minus the 90 that I have down here, minus that 45 that I have up here, and that's going to give me 45 degrees for this angle here. Okay, and I'm going to do something similar over here. Again, this is a half a circle, so I know I have 180 degrees over here, so I have 180 minus the 75 that's right there, minus that 30 that's right here, which gives me another 75 degree angle. Okay, so now that I have all of these central angles figured out, I'm gonna go ahead and then answer these questions here. Okay, so if I look from measure of FD, measure of FD goes from F, and again, if I give two letters, it goes the shortest distance. Okay, so this is a shorter distance going up and around than it would be going down and around. Okay, so this is the one that I'm looking for. The measure of FD is then again equal to the addition postulate here, which says that if I have two chords or two arcs that come together, then I can take the sum of those arcs. So this is equal to, let's make that a better equal sign, 75 plus 45, which gives me 120 degrees. Okay, and again, I'm going to ask you to classify these. So is this a minor, a major, or a semicircle? This being less than 180 degrees makes it a minor arc. Okay. Second one there, FCB. Again, I give 3 points here. I want to go in that order as how they connect. Make sure I can say that correctly. From F to C to B. So if I go from F here and I go down and around, I'm going to cross B's path before I get to C. So I don't want to go that way. I want to go from F up and around to C and continue on to B. Okay, so here again, I have a couple options. Option one is that I can take 360 minus, okay, and 360 because this is the full circle, but I have only two pieces here that are missing from that circle. So I can take 360 minus the 75, minus the 30, or I could then take each of these arcs that are combined to make FCB and add those together. So I could take the 75 plus the 45 plus the other 45 plus the 90. It's just those four. And I could add them together. Okay. Either one of these is going to show me that this is 255 degrees. And again, if I classify this, then 255 is more than 180 degrees, which makes this a major arc. F-A, looks like an O. Okay. BA, let's go with red with this one. BA is from here to here. Okay, so the value of that is just the same as the central angle, so that is the 30 degrees. Okay, and again, if I classify that, then that would be less than 180 degrees, which would make it a minor arc. Okay. Measure of FAC. Again, I don't want to cross C before I cross A, so make sure you pay attention to how you do that. Okay. For this, then I would have to go from here. I would go from F to A and continue on to C. Again, I have several options here. I could do similar to what I did for number 2. I could take 360. But here I'd have to subtract this 45, and this 75. So minus 45, minus 45, minus 75. Or I could just add the 3 that I have here. I have this chunk, and this chunk, which means I would have 75 plus 30 plus the 90. Okay, so again, either one would be fine. It just depends on how your brain is going to process it. Okay, so this should equal out to 195 degrees. And again, classification-wise, this is more than 180 degrees, which would make it a major arc. Okay, and for the last one, let's see what color. We can do black, I guess. From B to A to C. So I'm going to go from B here. I'm going to come around this way now because A is the next one up here, right there. And I'm going to continue all the way back around to C. Okay, so here again I have 2 options. I could add up every little segment. Try that again. I can add up every little segment that I have. So that would give me the 45 there, plus the 45 right above it, plus the 2 sets of 75, plus that set of 30, or since the only part of this that I don't have in this arc here is this 90 degree angle, I can take 360 minus 90 degrees, both of which would give me 270 degrees. Okay, and again, classifying this is more than 180 degrees, so this would be also a major arc. Okay, so again, important note, these are central angles. So again, they are angles that come to the center, and their vertex is at the center of the circle. Okay, these are central angles. Things to pay attention to here. Again, this is just kind of a futuristic thing and kind of a review all at the same time. Throughout this unit, there are 3 main types of angles. We're going to talk about central angles, which again we just recapped on. Inscribed angles, which are what we just did, okay, or we're going to do, sorry. And then circumscribed angles, which will be the next video. Okay, that's the next lesson. Okay, inscribed angles. are angles whose vertex are not on the center of the circle. They go all the way through the circle and connect to the side of the circle. Okay, so the difference between the two, central angle and inscribed angle, is where that vertex connects. Okay, a central angle connects at the center of the circle. An inscribed angle connects on the opposite side or on the side of the circle. Okay. We also have a definition of intercepted arc. An intercepted arc is the arc between the two chords that create the inscribed angle. So here, angle BAC, angle B, got to make sure I had the pen out here. Angle BAC, this angle here, is the inscribed angle. Okay, it is inside the circle, goes all the way through. And then BC, the arc here, is my intercepted arc. Okay, so again, two vocabulary pieces to make sure you understand when we're talking about these and communicating about them. Okay, so the measurement theorem. The measurement theorem just states that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so let's make sure I can make this clear, or at least try to make it clear. I'm going to give you one of two possible scenarios. I'm either going to give you an intercepted angle and ask you for the arc, or I'm going to give you the arc and ask for the angle. Okay. Or a piece of that, right? So you might get some other pieces where you have to find both kind of thing. But with this, I'm just going to go through some small things. If I have the angle, okay, so let's say I'm given the angle and I work my way out, okay, and I'm finding the arc, then I'm going to multiply by 2. Okay, because again, an angle is half of the arc itself. So if I give you the angle, I can multiply by 2 and get that double size. The other option again is then I'm going to give you the arc itself and work my way in. If I do that, then you're going to divide by 2. Okay, so again, you have two options. One goes out and one comes in. If you go out, you multiply by 2. And if you come in, then you divide by 2. Okay. Another theorem here indicates that if two inscribed angles of a circle intercept the same arc, so they have the same intercepted arc, then the angles themselves are congruent. Okay, so let me highlight a couple of things here. If I have chord AD and chord DB here, they intercept the arc here at AB. Okay, that's the arc that comes between them. However, if I pay attention to the diagram here, I also have this chord and this chord that also have the same intercepted arc. So what this theorem tells me is that because these two angles intercept the same arc, that these angles then are in fact congruent. Okay, so as it says there on the board, angle ADB is congruent to angle ACB. Okay? Or what's not on here, but should hopefully be clear if we look at it, Again, I'm going to highlight a couple different ones now. If I look at the fact that I still have this chord, but now instead of this one, I'm going to highlight this one, AC. Take away that little chunk, that looked horrible. Not that that looks much better. Okay. They intersect here at CD. But again, I also have this from D to B, and then from B to C as well, which means then that in this part, then angle DAC, this angle, would be congruent to angle CBD, or this angle. Okay, so again, make sure you pay attention to small details. Okay, so now several pages of examples here. Number one, okay, you're going to find the measure that's indicated. So I'm going to ask for a measurement, and you're going to find that measurement. Again, it might not be a real quick process. You're going to use the concepts that I just got done talking about, but you're also going to use some of the stuff and materials from the first two sections here. Okay, you could use arc addition postulate. You might have to find something that's missing that's going to help you find the answer. Okay, so it's not always going to be direct. So make sure you understand that. So for example, number one here, this is not direct, right? In order to find angle A, I need to actually have arc BC. So I want to go from here and I want to go in to find this angle, which means, as a couple slides ago I said, you're going to have to divide by 2. But the question is, what value am I going to divide by 2? I don't know this arc, but I can find it because this this circle consists of 3 arcs. It has this arc here from C to A, has the arc from A to B, and then the arc from B to C. There's only 3 of them. And those 3 add up to 360 degrees. So I know that I have 360 minus the 160 and the 120. So minus 160 minus 120. If I subtract these two, that gives me then 200 degrees minus 120, which means that this is now 80 degrees. And then again, from working this in now, to go inside, I have to divide the 80 by 2, which means that angle A is 80 divided by 2, which is all of 40 degrees. Okay? So again, here I didn't directly give you the information that you needed. You had to find that information by using the content that we've discussed already to this point. Okay? Number 2, however, I do just give you the direct link. So I show you that this arc is 180 degrees. So again, I'm trying to find angle A, which means I'm going from here and I'm again working my way in, which means I'm going to divide by 2. So angle A is that 180 divided by 2, which makes it a 90-degree angle. Examples 3 and 4. Again, make sure you're paying attention to the measures that I'm asking for. They are not this simplistic on the paper itself for homework. All right, but again, it's a combination of things. So here, we're going to find the measure of BC. I want to know this arc. I give you the piece in here. I give you the inscribed angle. So again, if I'm working my way out, I'm going to multiply by 2. Okay, so the measure of arc BC is equal to 55 times 2, which is equal to 110 degrees. Okay, and similar for number 2 or 4, I give you the information here for the intercepted arc or the inscribed angle, and I want to find the intercepted arc, which means I have the measure of BC is equal to the 20 degrees times 2, which is 40 degrees. Okay, so again, I give you the direct link there. You don't have to find an extra piece, you can just go straight to the answer. Five and 6. Okay, again, find the indicated measure. So we have, again, several options here. Again, how your brain functions and processes it is 100% up to you. Okay, I'm going to go through 2 methods for this first one here. Okay, method 1 is to say that, okay, from C to B, going around this way, that is indicated to be a half circle. So this is a semicircle. This is 180 degrees. And I can see that from here and here, that angle A is an inscribed angle, and arc CB is an intercepted arc. So to go from here in, I divide by 2, which means I have 90 degrees here. Okay, it's a right angle. I should then know from previous units that a full triangle has 180 degrees. So angle C is equal to that 180 minus the 90 we just found, minus the 45 that was given, which then tells me that angle C is equal to 90 minus 45. So angle C is equal to actually 45 degrees. Okay. Option 2 here is then, I'm going to clear this. Option 2 is to use the fact that this is 45 degrees and that this in itself is an inscribed angle. So if I work my way out here, then I'm going to multiply by 2, which means this is 90 degrees up top. And again, understanding that this from here to here now, from C to B, so CAB, is again, in fact, a semicircle, then this is 180 degrees. Minus the 90 degrees that we just found from A to C, which means arc AB is also 90 degrees. And then I can work my way in and divide by 2. Okay, so then angle C here is 90 now, again, divided by 2, which is still that 45 degrees. Okay. Again, some of your brains are going to see one form quick, and others of you will see the other one real quick. Okay. Again, be your own advocate. I can't stress that enough. You need to figure out what works best for you and be able to explain it and support your answer. Okay. Because you might not be wrong. You might just be different, which is okay. All right. Number 6. Find the measure of angle A. Again, here I give you the direct link. It's right there. The arc is 240 degrees. So if I work my way in here, I'm going to just divide by 2, which gives me 120 degrees. Okay? Example 7. Again, these are one of my favorites. These, I give you a whole bunch of information all at the same time, and then you have to piece it up and chunk it up. Okay? So things that I would do, again, I would take this similar to the bell work, and I would fill this out as much as possible so that we can just go ahead and go through the questions and then answer them pretty quick. Okay? So here I would find all the missing arcs. We can see that M is the center of this circle. So I know that from P to Q to N is a semicircle. So that means that the value from here to here is 180 minus the other piece that's here, 125, which means that Q to P is 55 degrees. Okay? Likewise, if I go from P to O to N, this is still a semicircle because it's that half. I know that from N to O is 180 minus the 54 that's here, which gives me 126 degrees. Okay. So now that I have those, let's go ahead and go through the questions here. So number 7, the measure of angle PNO. So angle PNO is from here to there to here. Okay, and again, going back through stuff that we've discussed and talked about, this is an inscribed angle. And if this is an inscribed angle, then the intercepted arc is what we need to use. So if I go from here in, I'm going to do what? If you said divide, then you're correct. So I would take, this answer would be 54 divided by 2, which is going to give me 27 degrees. Okay, 27 degrees. Okay, number 8. Number 8 is asking for the measure of QO. So if I look at the measure of arc QO, I have Q to O. Again, that's the smallest distance, not the largest distance if I only give 2 letters. So from Q to O, I have 2 arcs that I intercept. I have from here to here, which I know is 55 degrees. So this is going to be equal to 55 plus from P to O, which is 54, which is going to give me 109 degrees. And again, since this is an arc, I can ask the question to classify this, and since it's 109 and not more than 180, then this is a minor arc. Okay, so I'm going to write minor next to it. Okay. Now looking at OQN. OQN. So from here, I'm going to go all the way around here. Okay. So I have 2 options. Again, options are I can add segments that go together, or I can subtract from the whole. Okay. So again, it's completely up to you which pattern you take. But again, I'm going to write them both down just for educational purposes here. Okay, so OQN is OP, which is the 54, plus the PQ, which is that 55, plus from Q to N, which is the 125. Or I have the whole circle minus only this little chunk here that's not included from O to N. Okay, so minus the 126 degrees. Both of which is going to give you 230 234 degrees. 234 degrees. And again, this is talking about an arc. So I'm going to go ahead and classify this arc since it is more than 180 degrees. That is going to give me a major arc. Okay, number 10 is then asking me for another angle. So again, I'm going to pay attention to an inscribed angle from Q to N to P now. So I know again now I have this arc that we already found. So if I'm taking this and I'm going my way in, again I'm going to divide by 2. So that tells me that I have 55 divided by 2, which is 27.5 degrees. Okay, and that is talking about an angle, not an arc, so we cannot classify that. Okay, well, I guess we can. We can call it acute if we want, because it's less than 90. Okay, number 11, we need to find the measure of arc PQ. Okay, well, the measure of arc PQ, again, we just used that, right from here to here. So this is, in fact, that 55 degrees. Okay, last page here. Again, this is using that theorem that stated if I had two inscribed angles that intercepted the exact same arc, then those measures of those angles are in fact congruent to each other. Okay. I'm asking for two things here, so again, make sure you pay attention to the question. I might ask for one, I might ask for two. If I'm finding the measure of angle A, let's do angle A in blue and angle C in green there. Okay. Angle A should be real easy because if you look at the graph or the diagram given, angle A is in fact already given to you. Okay. Angle A is equal to 65 degrees. It's right there. Okay. Angle C, though, we do need to do a little bit of work, right? Because angle C has an expression in it. Angle D also has an expression in it. Okay, so the thing we have to pay attention to here is again that angle C has this intercepted arc. And again, if I look at angle D now, angle D also has the same intercepted arc. So because they have the same intercepted arc, that means that those two expressions are then equal to each other, which means that I have 7x minus 10 equal to the 3x plus 22. And again, when we have an equation, what we're going to do is solve it. Okay. I'm going to move the 3x to the left, so minus 3x. Minus 3x. That gives me 4x minus 10 equals 22. I'm going to then add 10 to both sides. That gives me 4x equals 32. I'm going to divide by 4, which tells me that x equals 8. But again, make sure that you're answering the question. Did the question actually ask for the value of x? Or did it ask for the angle C? Okay, it asks for angle C. So I have to find the value of x first, and then I can plug back in. So angle C was equal to that 7x minus 10. That means that angle C is equal to 7 times 8 minus 10. Angle C is then equal to 56 minus 10. So angle C is in fact 46 degrees. Okay, and that's the conclusion of this section of video. Just a tip though, if you pay attention to the things that we've discussed in the last couple of videos, notice that if you don't have a clue of what to do, then when in doubt, if I give you two expressions, you should set those expressions equal to each other and solve for x. Okay, at a very minimum, that would be worth a point. Okay, so when in doubt, if I give you two expressions, set them equal to each other and show me that you can at least do some algebra. Okay, as always, if there's any questions, comments, or concerns, please by all means feel free to reach out to me and let me know.